Hi everyone, good morning. It's great to virtually see all of you here. I wish we could be together in person. My name is Gwen Shapira. I am a Kafka committer and a PMC member. I wrote Kafka the Definitive Guide, and I am an engineering manager at Confluent. And on the morning opening of Kafka Summit, I want to join you in reflecting a bit. I want to reflect together on how the world is changing, how things are evolving, how Kafka is evolving with the world. I want to think about things that don't change. Architecture, great software engineering, timeless ideas that we will always use when we build our products. And I want to look at some of the really big changes that are happening in the Kafka community right now, and the possibilities that these changes are opening for us for the future. So let's get started. And I want to start by reflecting a bit about how the world changed in the last, let's say, 10 years. And it's been a lot, so bear with me. The first thing is hardware. 10 years ago, SSDs were new, not very common, super expensive, and also a bit scary. Very few people knew. There were a lot of rumors, a lot of mythology around it. It wasn't the obvious, reliable hardware that we kind of take for granted today. Firstly, the cloud. 10 years ago, the cloud was a very different thing, very new, very exciting, full of possibilities, not part of our day-to-day life, not something that every one of us has to take into account when they're designing their architectures. Raft. 10 years ago, if you wanted to build a distributed system, there were no easy to implement consensus algorithms out there. There was Paxos, and Paxos was quite difficult and, again, scary. These days, we have Raft, invented in 2014. Java got a lot better, a lot easier to use, a lot less garbage collection headaches, a lot easier to get good performance out of. And of course, Kafka use cases changed a lot. If you think about it, 10 years ago, microservices were really not a thing. Today, it is the thing. So obviously, with all those changes in the world, Kafka had to evolve and change with it. So if we look all the way back to original Kafka, you may remember, maybe you even used it. It used to be a single machine system. We had no replication protocol. And it was just a simple log. So then we added replication, which opened up this entire world of distributed systems and of scale. And then we added low compaction, which added all those key value store dependent use cases. And then we added Kafka streams, and we added exactly once, and we added Kafka Connect, and there was this entire ecosystem of microservices and stream processing that really grew around Kafka. So if you think about each one of those changes, it's not like a small thing. It was big in terms of what happened to the Kafka architecture. And even more, it was big in terms of what it did to the way we develop applications and develop software. It turned Kafka from this really glorified pipe, getting data at high scale from here to there, to a very versatile system today driving gazillion use cases and all sorts of applications. And every one of those changes opened up something new that we could not do before. So it's worthwhile paying attention to those big architectural changes and think about what can we do with them. And obviously, Kafka's architecture evolved a lot, but it wasn't done in a random, haphazard way. It wasn't done in a hacky way. It was done while maintaining a lot of the core architectural ideas and integrity. And this is important because architectural integrity doesn't happen by accident. You have those key principles that you really try to keep in mind while designing your software, while working on the project. And conceptual integrity means that you can look at every part of the system and really understand the whole. which makes it easier to develop the system, which makes it easy to learn the system, which makes it easier to operate the system. So preserving this architectural integrity is really key for what we in the Kafka community do and care about. So let's look at some of the architectural choices we made in Kafka and why we believe Kafka has this really important property of architectural integrity. And when we think about Kafka, and I spent a lot of time thinking about Kafka, what I'm really thinking about is this big idea. How do I explain to someone what Kafka is all about? And in my mind, it's the abstraction at the core of Kafka. I'm talking, of course, about the log abstraction. And this is important because once you pick the correct abstraction to describe your world, if you do it right, you open up inherent efficiencies of the systems that you're building on. So instead of working against the stream and just fighting this big uphill battle, you are enabling yourself to build something that is incredibly efficient. You can easily fill CPU caches, use prefetches, have best use of disk, best use of CPU, low-level kernel operations. Everything is suddenly working in your favor. And we really believe that our log abstraction opens up all those things for Kafka. So we have this core abstraction, and we believe that it allows us to build a high-performance system. And here's how it works. Here's how you build a high-performance system in a nutshell. You start by really understanding your hardware, all the foundations, hardware, operating system, the Java virtual machine, the platforms that you build on. And you need to understand what is it actually capable of. In the best case scenario, if you do absolutely everything right, what is the bar? What is the throughput? What is the latency that you can really get out of all the components that you have in the physical world? This is the starting point, and it's up to you to obviously meet the bar and not detract from it. And once you have all that, you learn, as I explained, how to work with the system, how to do the right design, use non-blocking I/O, use prefetches, use memory locality, page cache optimizations, have a great optimized wire protocol. You make all the choices in order to make the most out of the hardware and operating systems that you have. And after you did everything right on the design as well, there's still one very important thing that you have to do, which is run a system with a profiler, with a benchmark, and understand whether you fell short of your goal. Because it is so easy accidentally. You can spend months, weeks trying to create the most amazing theoretical system, and then you will have one really silly line of debug logging that does not have the correct condition and does a bit too much work, and you just threw it all away. So in order to get great performance, you have to be knowledgeable, you have to make smart design choices, and you have to be a bit obsessive about making sure you don't throw it all away and just keep testing and iterating over and over again, which is what the Kafka community became really, really good at. So with this solid foundation, let's look at some of Kafka's architectural principles and goals and how they were implemented until now, and then we'll talk a bit about how they evolved. So the first goal, and this was always true for Kafka, we always, from day one, wanted to have one huge Kafka cluster per company, with the goal of having a shared source of truth that everyone can integrate with and really help you avoid silos. The whole idea that every part of the organization is kind of off into la la land with their own view of the world is not a very good one. So we built Kafka with this goal in mind. You're going to throw different workloads on it. It's going to perform great. And if you need more capacity, you will add more brokers and you will get more capacity. And the idea is that the fact that you throw different workloads at it will not contradict each other. You can actually see today, if you think about it, the internet has gazillion how to scale Kafka guides, but you don't really have a lot of how to scale Kafka for this use case versus how to scale Kafka for the other use case. The main thing is that it doesn't matter if you do lots of reads, lots of writes, somewhere in between. Kafka, pretty much out of the box, will work fairly well with that. And a well-tuned Kafka is well-tuned for the hardware and operating system, not so much for your workload. So because Kafka was written for day one to support diverse workloads. And the goal was that as we add more and more brokers to get more and more capacity, we want it to grow linearly. We want broker number 3 that you add to add as much capacity as broker number 153. It just have to go up and to the right all the way. So we may have some design choices that currently limit us from achieving this goal, but we never abandon this goal. And we are working on obliterating all those obstacles. The second goal we had in mind was being very operationally friendly. Basically, you download Kafka, you unzip it, and it should just work. And this is really what attracted me to Kafka from day one when I started contributing to the project. I was actually evaluating for a customer a lot of different projects. There were a gazillion Kafka lookalikes at the time. I don't know if you guys remember. There were Scribes, there were Flume, there were all those things. So I did a bunch of evaluations. And one of the things that caused me to work on Kafka is that out of all of them, this was literally the easiest to use, and it had the best documentation guiding you on how to start. So that was great, but obviously just the first 5 minutes is not the entire operational experience. Being very observable is super important. How do you know if things are working well, if you need to do something different? Having all those metrics that we keep adding to, having very detailed logs in the request log to allow you to dive one layer deeper, being very easy to automate, interacting well in all those cloud environments. And maybe most important today is our obsession with performance means that Kafka is very efficient, which means that you can actually run huge scale and amazing throughput on tiny, cheap machines. The tiniest and cheapest machines that you can find in the cloud will already give you incredibly high performance. And this does not happen by accident. It happens because you have people who are obsessed about these kinds of problems. And this is super important. Obviously, these days and day and age, everyone is trying to slash pennies and dollars out of their budget. Running something that is cost effective is super important. And last but not least is the idea of elasticity. I already mentioned that Kafka should be able to scale as you add brokers. We want it to be easy to add brokers. And we want it to automatically adapt to new workloads. And we talked about why is it important, but something I want to point out is why having it dynamic is so key, because you don't want to spend all your time manually tuning things for this workload and that workload. We are living in a world that is becoming increasingly serverless. And if you look at how things run in the cloud, it used to be like when I ran things in the data center, it used to be that we basically ordered machines maybe once a quarter, maybe once every 6 months. So if you order machines every 6 months and then it takes you 3 more days to move data around and make use of the new machines, nobody will care. Obviously, we're now living in a world where we need to be way more elastic than even that. And in a second, I'm going to tell you how we're getting there. So we have all those design considerations, right? The scale, our big concepts around efficiency, being operationally friendly. Let's see about how those played out in the 2 biggest changes that are happening in the Kafka world today. So for those of you who are not following the mailing list, there are 2 really, really massive KIPs, Kafka improvement proposals, going on in the Kafka community, being discussed, being developed, being reviewed. One of them is Kafka tiered storage, and the other is the replacement of Zookeeper with a metadata quorum. And I'm going to talk about them at a high level right now, like this is a keynote. I'm not going to talk about every single detail, but it's a Kafka community, it's a KIP. You can read everything in the wiki, you can read all the mailing list discussions. There are so many fascinating questions that are being discussed, really amazing distributed systems, nitty-gritty. How do we send notifications? How do we know that everyone read it? What do we do if someone is getting split off? And most important, the conversation is still going on. Everyone here, or virtually here, can participate. So let's start with tiered storage. This is the idea that recent data is much more valuable than old data. It's going to be read much more frequency, and the latency of reading it has to be much, much lower. So you want to read it faster, and it's way more important. You're willing to pay more in order to get those properties. Although, on the other hand, maybe you cannot legally delete it. Maybe every month there is a data scientist who really needs to read it. But most of the time, nobody cares. And even when the data scientist has to read historical data once a month, he may need high throughput because he needs to read all of it. But he doesn't care if it's 5 millisecond latency or 600 millisecond latency. He will need to read petabytes of data, and it will take him a few hours, no matter what you do. So throughput is really important. It's obviously very important not to pollute Kafka's caches while you do it, so not to harm those real-time workloads. But other than that, you can put it on cheap storage elsewhere and completely forget about it, which is a fantastic idea. We should have done it ages ago. We want to thank the team from Uber, Harsha, Satish, Ying, if there's anyone else from Uber or somewhere else who was working on it. I'm sorry, those are the names I've seen the most come up on the mailing list. They've been doing an amazing job driving it with the community. And while it sounds like a great idea to have different storage come with different tiers, the really big thing, the really amazing addition to Kafka is that it opens up elasticity. So as I mentioned earlier, you take all data and you move it to cold storage. Imagine S3, imagine HDFS, and you keep only the most recent data, maybe a few megabytes, where Kafka is. It can even all fit into memory. You get amazing performance if it all fits into memory, but otherwise you have SSDs. And because the data in Kafka itself is very small, it means that when you add a new broker in order to scale, you only copy bits of data, few megabytes. You don't have to copy the entire partitions that nobody will ever read, right? That's amazing. Instead of spending hours, maybe days, copying data that will almost never be read to the new broker just so you can start using it for your real-time traffic, you move only the minimal data needed in order to start serving your real-time traffic. It takes maybe a few minutes, and that's it. Your broker is online serving your real-time traffic. Very elastic. You can do it a few times an hour if you have this kind of workload, few times a day if you have that kind of workload. Move things around, add brokers, remove brokers. It's a whole new Kafka. You can tie it into auto-scaling groups. Totally different world to live in. And if that wasn't enough, there are even more benefits to it. This is my, but wait, there is more slide. And the big deal is that if you now moved most of your data to very cheap storage, it means you can skip lots and lots and lots of it. And maybe certain years for tax authorities, maybe never delete because it's a bit risky and why even bother. And it's on a totally different type of storage. Theoretically, you can use something that is not Kafka to process it. And this is key because while we're implementing Kafka, or the nice guys from Uber, Harsha, Satish, and Ying, implementing this storage for HDFS or S3, they're building it in a way that is pluggable, which is the most important part of this architecture choice. Because if it's pluggable, it means you can use something else. It means that if you want to try Elastic, MySQL, Twitter, for that matter, you can actually experiment what kind of storage would be the best place to tier old Kafka data. So it can get quite exciting. I'm looking forward for a lot of innovation in that regard. And maybe no less important is the idea that it saves us time. Because I don't know if any of you tried to do capacity planning for Kafka. First of all, if you have a lot of it tends to be storage driven. Like if you have very high throughput, all of it is how long can I keep the data and how much storage do I need to buy from it. And if you think about the list of requirements, it's a bit insane, right? It has to be low latency because you don't want to have massive latency when you start using the reading from disk. It has to be high throughput. It has to be large to store all the data, and it has to be cheap. The number of storage systems that answer to all those criteria is approximately 0. So we need to find better ways to do things. And by having to make different decisions for the fast online data versus the old high throughput high latency data, it reduces a lot of the headache around this decision making. Which brings me to the really important question, which is, which beach am I going to go to now that I don't have to do capacity planning for most of my time, really? Send over recommendations. Okay, the other big feature that I want to talk about is Zookeeper Removal, and with it, our new controller. So that's Keep 500. Keep 500 got all the marketing, but there's a bunch of keeps that have all the interesting bits in them. So you kind of have to find Keep 590, Keep 595, Keep 631. So it's kind of like this really big project, multi-part keeps. And at the core of it, the key idea is that we're going to replace Zookeeper with a Kafkaesque version of Raft. So if you think about it, consensus is about agreeing on a shared state. Metadata is about agreeing on a shared state. And both Zookeeper and pretty much every other system do it by writing to a shared log. And surprise, Kafka is very good at writing to a shared log. We already know how to agree on a shared state and distribute this shared state between a lot of members of the system by managing those shared logs. So it always felt a bit silly that some of Kafka's state is managed on a log in Zookeeper, while most of Kafka's state is managed on a log in Kafka. We've written a log processing system, but the key parts of our state are in someone else's log processing system. The entire Kafka journey started with Jay's realization that log is the big abstraction at the core of every data system. We're just bringing those ideas back into Kafka in a more holistic way. We are making Kafka a lot more Kafka-like. We like logs, so we put more logs in our log processing system. It just makes perfect sense. And obviously, we're not just doing it because it sounds like a very cool architectural idea, although we kind of are doing it because it sounds like a very cool architectural idea. But in order to do it, we had to convince ourselves that there are some practical benefits to this really cool architectural idea. So if you think about how Kafka is communicating state right now, suppose that I had leader election and the controller needs to let everyone know about the new location of the leader. It basically starts opening connections to every one of the brokers and saying, hey, there's a new leader, here are the followers, here's the new ISR, congratulations. And it does it in a way that's blocking. And while we did a lot of work optimizing it, we're kind of reaching the end of this architectural direction. But this is okay, because we already know a much better way than point-to-point communication to communicate state in a large distributed system. We know that the right way to distribute it is by writing to a shared log and have everyone else consume the state from the shared log. It's asynchronous and it scales amazingly well. We know that because we already wrote a system, many of them, that work exactly in that way. So imagine that the current cluster state is being written to a log. Every broker consumes it. You know where the leaders and you know where the followers and you know everything else about Kafka metadata, topic configuration by reading this log. And you create your own copy of the current state in memory, which means that if controller has to fail over, it's instantaneous. The new controller already has the state from memory. It doesn't have to refetch it from Zookeeper, one of our biggest bottlenecks at the moment. Everything that you need to communicate is much faster and much less blocking this way. A lot of things are almost instantaneous, which allows us to scale our partition count in ways that were not previously very easy to imagine without those gigantic machines. So we are fairly confident that we can use this architecture to scale into the tens of millions of partitions on a Kafka cluster. Now, the other benefit of doing this new architecture is that we do, in fact, get rid of Zookeeper. And the main benefit of getting rid of Zookeeper is that you no longer have to manage Zookeeper. I know everyone tells me, oh, Zookeeper is super stable, it's super easy to manage, blah, 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 yeah, okay. But it's still, you have to learn two systems. You have to learn Zookeeper, you have to learn Kafka. You have to learn how to monitor, how to secure, all those best practices, and you have to learn it twice. This is a lot of work. I already told you how much I love doing capacity planning. Imagine having to do it twice. Well, you don't have to imagine. You're already doing it twice. And to make things worse, Zookeeper and Kafka are conceptually very different. I remember in the first Kafka Summit, that was, I believe, 5 years back, someone stood on stage and he told us this really funny talk, 101 mistakes I've made with Kafka. And one of them was to set up 8-node Zookeeper. Now, it's not a Kafka mistake. 8-node Kafka cluster with 8 brokers is just fine. It is a Zookeeper mistake. And because how would you know that 8 brokers are okay with Kafka, not okay for Zookeeper? So obviously, no Zookeeper is a good operational improvement. But even more than that, remember I explained about every leader election and every change getting written to this shared log? You now have an immutable log with every leader election and every change that happened to your distributed system. If someone asks you, what was this performance blip yesterday and how was it different from a performance blip 3 weeks ago, you have this log to go to and inspect. And this is the sort of truth. It's not that, oh, Kafka did one thing in memory and maybe it logged stuff correctly, maybe not. This is the truth. So it's going to be really fantastic. And the key point, the key thing to remember here, obviously each one of those keeps is cool in its own right. Taken together, this is a state shift. This is a step jump in Kafka architecture, just like adding replication was, I don't know how many years ago. It will make Kafka more pluggable, more elastic, more cloud-like. And the key things to remember about this new architecture is the elasticity, adding and removing brokers, adjusting to new workloads. This is all now within our reach. Integrated, both are conceptual integrity. The ideas that the same ideas are of the log are now being used throughout Kafka everywhere, and integration with external systems like S3 and HDFS, all those different storage systems, and infinite. And by infinite, I mean infinite. Infinite storage, being able to just store as much data as you want without artificial limitations, being able to add as many brokers as you want without artificial limitations, without decreases in performance, and being able to add as many partitions as your use case requires. So those are just 2 examples of Kafka's core really evolving in an amazing way. And I really have this wish list in my head of all the other ways Kafka could keep evolving. And I'm so tempted to dump this entire wish list on you because it's an exciting wish list. This isn't the thing that makes me get up every morning and go to work after I've been working on Kafka for 6 years, guys. It's still amazing that we can keep on making it better. But I'm going to not dump this wish list on your head right now. I feel like it may be a bit unfair for me. And part of the reason is that Kafka is going to keep evolving. And the world will keep evolving. And you're the guys who need to make Kafka keep pace in the world and make it adapt to all those changing conditions in reality. And the fact is that Kafka will always be driven by community members saying, oh, I actually need something else because things have changed. And what I really want you to take here as a takeaway, other than people are doing freaking cool stuff with Kafka these days, is the idea that Kafka is an evolving system. And that you, as a community member, own it as much as everyone else. And you can improve it to meet your needs. And it's not just something static that you evaluate, does it or doesn't it meet my needs? It is the thing that you own and can make better, and we want to make it better together. And as long as we keep Kafka's North Stars in mind, our idea of performance from first principles, from the ground up, the ideas of elasticity, operational simplicity, high scale, we think Kafka is the event log streaming system for the future.